Hello, my name is Nick Adnett from Darkside Canoes. I've been designing, developing and building sit-and-switch racing canoes for a number of years, and during that time I've experimented with many different ideas. I've been looking at the aggregation of marginal gains from boat optimization, cockpit ergonomics, single blade paddles and paddling technique to help make the boat go faster, and I'd like to explain the logic behind my thinking and where I've got to. In this video I'd like to share some of the innovations I've been working on regarding paddling technique. The one thing I'm not doing is telling people how to paddle. If you have a boat you like, a setup with which you are comfortable and a paddling technique that works for you, then don't let anything you hear from me change that. What you're seeing now is where I've got to. The boat is carbon fibre ICF compliant C1, 5.2 metres long and weighing about 8 kilograms. I've set this up with a swivel seat cockpit configuration, and I'm using my latest paddle innovation, which is what I want to talk about. The technique is similar to a racing kayak style, as I've come to the conclusion that the only difference between paddling a racing kayak and a sit-and-switch racing canoe is 2 blades versus 1. But before I get on to all that, I'd like to go to the beginning. I started with a Winona carbon paddle, cranked at 12 degrees because that's what everyone else was using. The blade is basically a flat surface. This type of paddle is used extensively for sit-and-switch canoe racing, particularly in the US, Canada and Australia. It was invented by the American paddler Gene Jensen in 1971, and it's hardly changed in over 50 years. I spent a lot of time looking at how paddlers use this blade, and have concluded that there is room for improvement. Coming from a racing kayak background, I was surprised at the difference between the range of muscles used in kayaking and those used in a canoe. Most of the canoeist's power appears to be driven by the arms, and there isn't a lot of trunk rotation or leg drive. A longer catch can be achieved by bending forward at the waist, which can make the boat start bobbing. Paddlers tend to adopt a fast cadence and a short stroke length. The blade is pulled back along a single path, which simply accelerates the same body of water, thus pulling the paddle through the water rather than pulling the boat past the paddle. There is little leg drive or rotation, and a whole lot of available muscle groups remain redundant. Here the C2 crews are taking tiny paddle strokes. This was my starting point, although I naturally brought some of my kayak style with me, but I was determined to make it work. There is very little sit-and-switch marathon canoe racing in the UK, so I spent a lot of time attempting to keep up with my kayak contemporaries. I was convinced that the cranked paddle could be improved, and experimented with a number of designs which increased the surface area of the paddle. I built some raised boundaries at the edges of the blade to try to prevent the water simply spilling over the sides. I put multiple crank angles in the blade so that part of it was always at the optimum perpendicular angle during the stroke cycle. I spent hours testing on the water in a quest to improve performance. I tried removing the blade boundaries because they were just lifting water at the end of the stroke, and tested again. More testing just confirmed my suspicions. Absolutely no performance difference whatsoever. Looking at the design of the conventional paddle, it is clear from the bank testing that it is fairly easy to pull the paddle through the water. Also, the forward crank means that at the start of the stroke, the catch, the blade is pressing the water down rather than locking the blade. It is only as the paddle moves back that the blade becomes perpendicular to the water and having the most effect. By this time, the water behind the blade is already accelerated, water is spilling over the edges, and there is little purchase. No wonder paddlers can maintain such a high cadence. It was a racing kayak coach who suggested that I reverse the paddle in order to get a better catch. And what a difference it made. All of a sudden I felt a change in resistance as the blade locked onto the water. Maybe Kayak Dude had a point. This additional resistance meant that just using arms was not enough, and a trunk rotation and leg drive was required to engage bigger muscles and sustain the stroke. I also noticed that a reverse blade enabled a much better C2 steering stroke in the stern. It was then that I changed tack. Rather than trying to adapt a canoe paddle to a better way of paddling, I should now look at how kayak paddles could be adapted. I started with the asymmetric blade. This is not cranked and has a curve to the blade. So first off, I tested the kayak blade in a canoe. I then got an old paddle and reshaped the blade so it was symmetrical. It felt really comfortable, a better catch and more purchase on the water, especially when I used it with a swivel seat, which I was also developing. So you can see how I took advantage of a simple kayak paddle design, but there is much more to come. I'm a recent convert to wings after abandoning them many years ago due to my incompetence and inability to master the stroke. However, I started listening to a racing kayak coach friend of mine and now realise how wrong I was. The introduction of the wing paddle to racing kayak in 1983 had a profound impact on paddling technique. A paddling style based on full body rotation and a powerful leg drive enable athletes to fully exploit the fluid dynamic behaviour of the blade. I like the forward catch and how the blade locks in the water, allowing the boat to be pulled past the paddle. I also like the paddle technique in the way that a huge muscle set from fingertips to toes is fully exploited. The kayak world have developed this efficient style over a number of years, and there is a lot which can be adapted and applied to a single blade. But let's also consider how a racing kayak is set up. One racing kayak innovation which we can take advantage of in a sit-and-switch canoe is the footrest. The feet are the main interface between the paddler and the boat, and the only part of the body which doesn't move. They do, however, transfer all the power generated by the paddle into the boat via the leg drive. Realising that we are all different shapes and sizes, the engineers at Nello have put a lot of effort into footrest ergonomics and provide a huge range of adjustment. Both upper and lower footplate angles can be changed, and there's a whole host of pull straps and bars to ensure that the whole foot is supported and locked into the best position for pushing and pulling. It is similar to a cyclist being clipped into the pedals. Not only is the foot in the best position to deliver power to the crank, it also enables power to be applied during the upward stroke. I tested some of these cockpit concepts in my kayak. Footplate, pull bar, heel bar and heel rest, all in conjunction with a swivel seat. Surprisingly, most kayakers choose to rotate on a static seat, relying on a shiny surface to achieve a swivel. Migrating these to the canoe without a tiller bar, the footrest integrates the footplate and the heel bar into a contoured shape similar to the sole of a shoe. The adjustable pull bar locks the feet in and the swivel seat completes the setup. One change I did make was to enable the swivel seat to be locked to better cope when conditions get rough. In order that the seat is returned to the start position during portaging, there are a couple of elastic anchors. The feet are secured under the pull bar and slid to the extents to ensure that they are in line with the hips. The whole setup ensures an ergonomic platform for trunk rotation and leg drive. At this stage I was satisfied with the boat, the setup, the current paddle and the technique. Now I was ready to move on to the wing paddle to find out what it could offer. A wing blade works with a leading and trailing edge and the lift effect produced as it tracks through the water. As the blades on each side are different, it wouldn't work in a canoe because we use the same blade on each side. But could some aspects of the spoon shape be used? So I made a set of wings and started to feel how they worked and consider how they could be adapted for single blade paddling. In order to test a spoon-shaped blade, I needed a curved paddle shape from which to make a mould. And Mr. Kayak Coach suggested that I split a couple of wing blades down the centre and join the two trailing edge sides and the two leading edge sides to produce two different options: a deep section profile made from the two leading edges and a shallow profile made from the two trailing edges. I started with what I refer to as the deep section, which consisted of the two leading edges. I expected this to provide the best option, but the wing effect was so strong and violent that the paddle just shot sideways and was almost impossible to control. What you are seeing here is a pared down version where the curves on the leading edge have been significantly reduced. This shows how the size and shape compares with a symmetric paddle. I'll come to the shallow section paddle in a minute, but we tested both versions by swapping them during a session in the C2. You can see the deep section in the front and the shallow section in the rear. Although the performance of the modified deep section was okay, the removal of the edges made it effectively passive. Consequently, it was abandoned in favour of the shallow section. So moving on to the shallow section, this was a revelation. There is a slightly curved over tip which engages the blade with the catch. Moving towards the shaft, there is a sweet spot where the blade locks onto the water. The sloped profile prevents the water spilling over the edges, and even as the paddle moves towards the end of the stroke, the water remains captured within the steepening sides towards the shaft. The shape of the paddle is radically different to the symmetric blade. What I'm trying to show here is the power required to pull the paddle through the water. There is significant flutter because the purchase the blade has on the water makes it difficult to pull. Therefore it can't be used by traditional short sharp strokes just using the arms. So I pull the boat towards the paddle using a longer stroke, trunk rotation and leg drive. It is a joy to use. So there you have it. I'd like to say that everything was carefully planned from the start. Yes, the embryonic idea of a spoon-shaped blade was, but the suggestion to use a wing blade as a candidate shape was a throwaway comment from a racing kayak coach. I mean, what do they know? We're still in the early days of testing and trialling and looking to refine the paddling style to fully exploit the paddle's potential, and there's still a way to go. It would help to get some feedback and invite others to try it. I hope it all made sense. Thanks for watching.